Good morning, ma'am. My name is M. Karthik. I am from EC department. Today, my topic is determine the driving point admittance functions of RL series and parallel network. Determine the driving point admittance functions of RL series and parallel network. Introduction to RL series and parallel network. RL series and parallel networks consist of resistors and inductors connected in series or parallel configurations. The driving point admittance functions helps determine the network behavior in terms of impedance of and frequency response. In this presentation, we will explore how to determine the driving point admittance functions of RL series and parallel networks. Overview of driving point admittance functions. The driving point admittance function is a mathematical representation of the network's input impedance. It is denoted by Ys and is a function of the Laplace variable S. By calculating the driving point admittance function, we can analyze the network's response to different input signals. Driving point admittance of RL series network. For an RL series network, the driving point admittance function Ys is given by Ys is equals to 1 by R plus SL. Here R is the resistant in the network, L is the inductance and S is the Laplace variable. The driving point admittance functions helps determine the network's impedance at different frequencies. Analysis of RL series network. By analyzing the driving point admittance functions of an RL series network, we can understand the network response to input signals. The frequency response of the network can be determined by examining the poles and zeros of the driving point inductance functions. This analysis help in designing and optimizing the RL series and network for specific applications. Driving point of admittance of RL parallel network. For an RL parallel network, the driving point admittance function Ys is given by Ys is equals to 1 by R plus S by C. Here R is the resistant in the network, C is the capacitance and S is the Laplace variable. The driving point admittance functions can help determine the analysis help in digesting the optimize the RL series and network of the specific applications. Driving point admittance of RL parallel network. For an RL parallel network, the driving point admittance function Ys is given by Ys is equals to 1 by R plus S by C. Here R is the resistance in this network, C is the capacitance and S is the Laplace variable. The driving point admittance functions helps determine the network conductance and suspectance at different frequencies. Analysis of RL parallel network. Analyzing the driving point admittance function of an RL parallel network help understand the network behavior with varying input signals. The frequency response of the network can be evaluated by studying the poles and zeros of the driving point admittance function. The analysis aids in optimize the RL parallel network for series application and requirements. Comparison of RL series and parallel networks. RL series network have a driving point admittance functions that depends on the resistance and inductance values. RL parallel networks have a driving point admittance functions that involves the conductance and suspectance values. Understanding the differences between these two networks configuration is crucial for designing and analyzing RL circuits. Practical applications of RL networks. RL networks are commonly used in variable electronic circuits such as filters, amplifiers, and power supplies. By determining the driving point admittance function, engineer can optimize the performance of RL networks for specific applications. Understanding the behavioral RL network can help in troubleshooting and improving circuit designs. Importance of driving point admittance function. The driving point admittance function is essential for analyzing the impedance characteristics of RL networks. It provides valuable insights into how the network responds to different frequencies and input signals. By calculating the driving point admittance functions, engineer can optimize the performance and efficiency of RL circuits. Conclusion. In conclusion, determining the driving point admittance function of RL series and parallel network is crucial for analyzing their impedance characteristics. The driving point admittance function helps understanding the behavior of RL networks with varying input signals and frequencies. But studying and optimizing the driving point admittance functions, engineers can design efficient and reliable R circuits of a wide range of applications. Thank you, ma'am. Thank you for giving this opportunity.